The purpose of this video is to show how to work through the Chapter 11 problems in simple linear regression using R. So I've made available the data sets from Montgomery's book on Blackboard. And if you open up, for example, the Chapter 11 file, you're going to see he gives you, the data sets for every problem and example in the book. So I thought we would work through example 11.4. Actually, this is exercise 11.4. And there are just two columns. So you have the sale price of some property, and you know what the taxes were on that property. The first thing that you need to do is to get this data set into R, which means extracting just those two columns. I think perhaps the easiest way to do that is to make a separate spreadsheet with only those two columns. So I just highlighted all of the relevant data and I hit copy. So on a Mac it's Command-C, on a PC it would be I guess Control-C. And I'm going to go to another tab and we'll paste it. So now I have only these two columns. I'm going to give myself slightly simpler column heading. So let's call this first column sale, and let's call the other one taxes rather than 11.4, all that business. Okay, so at this point we're going to save it. So let's go do File, Save As, and I'm just going to drop this on my desktop here on a Mac. I'm going to call it example 11.4, and then if you go down to Format, I'm going to save it as a comma-separated value file. So that R brings in these files very easily. So notice I'm saving it as example 11.4.csv. Okay, and then I get this box saying, what do you want to do? Well, let's save the active sheet. And then we get another box and just continue. And now we have this file sitting out on my desktop that I can read in. So let's go read it into R. So to read in a CSV file, I would say, give it some name, so like call it DAT or something. Read CSV. Now I have to give the location of this file. So I put it on the desktop, and I think I called it ex11.4.csv. So I have a CSV file, so we'll use read CSV to get this in. Now I'll make this a little bit bigger, and if I just type DAT, you'll see that it has 24 cases in it. It has two columns. Now, sale and taxes, that's why I wanted to simplify my names a little bit. And if you trace through the numbers, these match up with the table given in the book. All right, well, let's see what we're to do. So assume that the simple linear regression model is appropriate. Obtain the least squares fit relating the selling price to the taxes paid. What is the value of sigma squared? All right, well, to fit a linear model in R, we just, you've got to call it something. My favorite name is fit. So fit is equal to an LM of, all right, the dependent variable, remember I called sale. The independent variable is taxes. So sale tilde taxes. Now on a Mac you get a little bit of help. I've just entered what the Mac calls a formula. The second thing is the data set. So the data set is, I call it DAT. So where did DAT come from? That's what I called it up here. And that's really up to you. You could call it whatever you like. All right, now we have this fitted object. Now I don't like Montgomery's just jumping right to the regression equation. I'd much rather we look at a scatter plot first. So what you want to do is say plot. Now you usually want to put the causal variable in the x-axis. So it's going to be dat $taxes and then dat $sale. And if you do this, you get a nice scatter plot. And you want to look at this for things like outliers. So I don't see any outliers. I don't see any horrible skewness. You want to look for whether the relationship, the trend is linear, which it certainly appears to be here. And if you have any of those problems, we'll learn how to address them later on. Okay, now if I do aligns on fit, this will superimpose the regression line. oops, it's AB line, pardon me. So AB line fit superimposes the regression line. You'll see the line passes right through it, giving a pretty good fit. Okay, well, how do we answer the questions? You want to use summary fit. So if you do a summary on fit, this will answer most of the questions that Montgomery will have for you. So in particular, this part A says, what is the estimated value of the error variance? Sigma squared. Well, the residual standard error is sigma, so I'm going to have to take that number and square it. So 2.961 squared gives you the variance. So that would be the correct answer to part A. Let's just read on here. Find the mean selling price given that the taxes paid are 7.5. Well, there's a couple ways that you can do this. You could do it directly. So you could type 13.3202, which is your intercept, then plus 3.3244, the estimated slope, times 7.5. But I wouldn't recommend doing that. It's too much work. So you might find this other method to be even more work, but what I'd recommend using in general is the predict function. So we want to predict something based on the fitted model fit, and then I'm going to specify a data frame. This is going to sound confusing at first, but I'm going to say I've got a data frame that has a variable called taxes in it, taking the value 7.5. This is slightly better form, so notice we get exactly the same answer that we got up here, to about 5 accurate digits or so. But this is just better form. So that's the answer to part B. Part C, find the fitted value corresponding to y equal to x equal, all right, this happens to be one of the observations. So if we look up here, it's actually the 7th observation. So for taxes equal to 5.898 something or other, we have to find the estimated value of sale. So there's a number of ways of doing this. The first is, we could do the same thing we did before. So I'm kind of lazy. I'm going to copy this. So let's just copy that value. And if I do an up arrow and paste that value, now I get the fitted value for that particular observation. However, there's, I suppose, an easier way. If you type names on fit, this gives you a list of all the objects associated with the fit object. Okay, so fit $fitted values. So fit, and then we want to reference this part, fitted values. And I think I said this was the 7th row. So if we take the 7th row, we should get exactly the same number, and sure enough we do. So that would be an alternate way of doing that. You really want to get to know your way around these basic functions. We're also to find the residual. So 2 ways to find the residual. Let's start with the easy way. So fit $residual sub 7. So this residual, actually I should say residuals, will give me the answer. Well, where did that come from? So an alternative way would be to take the observed value, which is going to be dat $sale sub 7, and subtract off the predicted value. So y minus y hat should give me exactly the same thing. So again, in real life I would be using fit $residuals since it's already been computed for me, but this is where it comes from. Okay, part D says calculate the fitted values. Well, R's already done that for you. It's fit $fitted values, and we're to plot this against the observed value. All right, so let's go do that. We can just do that with a plot function. So we're going to say plot. We want dat $sale, and we're going to plot that against fit $fitted values. So we're plotting y hat on the vertical axis against y. And then he asks us a variety of questions. If we didn't have any errors, what would this look like? We'd get a 45-degree line. Now the fact that the points roughly follow a 45-degree line means that the fit is decent. Okay, moving on. If we go to problem 26, it's an extension of this problem. So 26 says, consider the data from exercise 11.4. Test whether beta 1 is equal to 0. So beta 1 equal to 0, that means taxes have no relationship with sales. The way to get this is, well, go look at this table. Here is the p-value. The p-value is very tiny, so we're going to reject the null hypothesis since this is less than 5%. We've been told to use the 5% level. Another way to do this is just look for stars. If you have a star, it's significant at the 5% level. Okay, since we have a star, we reject the null hypothesis and conclude that taxes affect sales. Part B says, do the same test using the analysis of variance approach. Well, it's a good idea to know how to do this by hand. To do it in R, we're going to use a function called drop1. So drop1 fit, and then just say test equals f. Now, notice we get exactly the same p-value with the exact same 3 stars, but the test statistic is a little bit different. We talked about the differences in class, but if you really want to answer Montgomery to the letter, that's how you would do it. All right. Part C, estimate the standard error of the slope and the intercept. Well, R's already done this for you. So this is the standard error of the slope. 0.39 is the correct answer. Here is the standard error of the intercept, 2.57. Part D, test the hypothesis that the intercept equals 0 using the 5% level. Well, the way we would do this is to look at the p-value or look at the stars. Since we have at least one star, we reject the null hypothesis and conclude that the intercept is different from 0. So we've just worked problem 26. Moving on, let's move on to 42. So 42 says, continue problem 11.4, and it says find a 95% confidence interval. Well, to find 95% confidence intervals in R, you say confident fit, and here they are. So here is a confidence interval for the slope. Here's a confidence interval for the intercept. So we've just knocked off parts A and B. Part C, find a confidence interval, 95% confidence interval for when the mean rating is 8. Well, the way we're going to do this is with predict. So I'm kind of lazy. I'm going to go bring this back up, and rather than typing that whole thing. So it's when taxes are 8, I believe. No, 7.5. Looking at the previous question. So 7.5. Now, to get a confidence interval, you say interval equals conf, or confidence if you like to type. So here is the confidence interval for the mean prediction. We've just knocked off part C. Part D is find a prediction interval when taxes are 7.5. So the way to do this is just change conf to prediction, or pred. And so here is the correct answer to part D. Moving on to question 54. So 54 reads, now do something on exercise 411. Find the residuals, find the normal probability plot, plot the residuals of y hat versus x, and what is the fraction of variation explained by the regression model? Well, let's answer part D first. We've already answered it. So the fraction of variation explained is r squared. So the correct answer to 54D is 76.73%. So we're explaining 77% of the variation in sales if we know the property taxes. How do we do the other ones? Well, finding the residuals, we already found the residuals. Fit $residuals answers that. But what we really need are these plots. So one of the assumptions of the regression model is that these things should be normal. So we need to get a normal probability plot. I think that's part B, and then we need the residual plot. So the way to get all this is to simply plot fit. And this is an interactive menu. If you hit return, here we get our residual plot. You want this to show no pattern. And this really doesn't show a pattern. It's not like the variance increases, which would be a problem, or showing a pattern where all the residuals are positive, then negative, then positive again. So the residuals don't show any pattern. This would technically be the answer to part C. Now let's go hit return again. We get the answer to part B. Here's a normal probability plot. This plots the observed quantile of the residual against the quantiles of a normal distribution. If they're normal, that all these points should fall right on the line, and we've got a pretty good fit. The normality assumption is pretty well satisfied. There's a couple points where they're a little bit strange, but nothing to worry about. So I would argue that we've got a pretty good fit. All right, carrying on. This is we haven't talked about this yet, but this is going to show us whether there are outliers. Any points that exceed the value 1 are problematic. They're outliers. We don't have any values. So notice here, this contour indicates the value is 0.5. There's nothing out there. 1 would be not even on the chart. So the short answer is there are no issues with this data set. Okay, so that's it for the first 2/3 of chapter 11.